Alright, round two. So let's try this again. Hopefully now I fix this problem. Alright, so we were on F when I left off. So basically what I was trying to say is since there's no plus or minus, for there to be a limit, both from the left and the right must be equal to each other. So the limit of f of x as x approaches 2 from the left must equal the limit of f of x as x approaches 2 from the right. And since we just did those two, 8 does not equal 1, therefore the limit of f of x as x approaches 2 does not exist. And you can look at this graphically as well. So if we look at 2 here, you can see that both from the left side and the right side, they're both approaching 2 different directions. So therefore, there is no limit at x approaches 2. All right. So if we look at the limit of f of x as x approaches negative 1. So here is a negative 1. And we see both from the left and the right, it is approaching 0, right on the x-axis. So that one's an easy one. All right, so let's look at the limit of f of x as x approaches negative infinity. So what that means is, as we go this direction with the graph, what is x approaching? Well, we look and we keep on going, we see that this graph is, as we keep going, is approaching this asymptote, which happens to be the value of 2. Right, so that's how you look at it graphically. All right, so let's look as f of x is approaching infinity. So now let's look in this direction. So when we look in this direction, we see that this point stops, but we do have a line here that if it was to continue graphing, it would just keep going up and up and up as it goes infinity in this direction. So therefore, as x approaches infinity, y will also be approaching infinity. So therefore, the limit of f of x as x approaches infinity happens to also be infinity. All right, so this next one is, now you give it a try. Consider the graph shown below to find the value of each of the following values if the limit does not exist. So look at this graph, answer the questions that follow, and be prepared to discuss this in class tomorrow, with the answers on it. All right, but I'm going to leave this part to you and go ahead and move on to the next part. And you are more than welcome to rewind, fast forward, pause at any point in time. Alright, so let's look at this. It says, limits are the backbone of understanding that connects algebra and geometry to the mathematics of calculus. In basic terms, a limit is just a statement that tells you what height a function intends to reach as you get close to a specific x value. Recall from pre-calculus that you evaluated 3 types of limits. Complete the table below. A right-hand limit, again, we talked about this earlier. It's a limit of f of x as x approaches some value, we'll call it a c for constant, from the right side. So it has the plus sign. Verbally, what this says is the limits as x approaches c from the right. So proper notation for a left-hand limit looks just like a right-hand limit, except it has the minus sign. So this will be the limits of f of x as x approaches some constant number from the left side. Again, in verbal form, it is just limit as x approaches c from the left. Right, the general limit is the same thing without the little exponent. So it's just the limits of f of x as x approaches some constant. All right, and again, this is just in verbally, it's just the limits as x approaches c. All right, the device I'm using kind of messes up my letters, so you can fast forward or rewind to see what I just said, but this says the limit as x approaches, so approaches c. I apologize. All right, so let's move on. And again, if I'm going too slow, you can fast forward. If I'm going too fast, you can pause, rewind, anything you need to do. All right, so let's consider the function shown below. Say you want to find the limit of f of x as x approaches 4 from the right, the plus sign. The positive sign in the limit notation indicates a right-hand limit. So if you think of a function as a highway, and imagine you are traveling along the graph of f of x toward x equals 4 from the right, not to the right, and you stop at the vertical line x equals 4, the y value where you stop is 3. So therefore, the limit of f of x as x approaches 4 from the right equals 3. You will use this graph to explore the limits and probably the next page. So again, so what you'll see here, so if I was to go, here's 4, right? And I'm going to drive from the right side, and when I get to the vertical line x equals 4, what was my y value? 3. That is how you find a limit. So let's move on. All right, so we're going to use that figure to help us find the rest of the answer. So f of 2, this is just simply not finding a limit, but if I was to look over here at 2, what is my y value? So this is exactly what it is. What is it on? That's f of 2. And you'll see that's negative 1. So it's not asking for the limit. It's asking what is the y value when x is 2, which was negative 1. All right, same thing over here. It's looking at f of 1. So we come over here. Here's 1. And then I'm going to go, all right, so the value looks like it's dead on negative 2. And I'll do that point right there. So negative 2. Now we're looking at limits. So we're going to look at 4 from the left side. So we'll come back. So here's 4 from the left side is also 3 because it's coming to 3. Right, here we're looking at 2 from the right side. So I go to 2. From the right, it's actually approaching 1 from the right side. So that'd be 1. Now let's look at 2 from the left side. So if I'm looking at 2 from the left side, it actually approaches negative 1. So let's look at negative 1 from the right side. So if I look at negative 1 from the right side, I see it's going to 2. Now let's look at as it's approaching from the left side. So from the left side, it is also approaching 2. So we're not paying attention to that one. That would be if it said f of negative 1. Since we're looking for the limit, we're only seeing, all right, where is it actually coming towards? And the value is 2. All right, so if we look at negative 4 from the right side, we see that it's 2. All right, but if we look at it from the left side, is there anything that's coming towards the left side? And since there's no highway to drive on, the limit does not exist. All right, but let's look at negative 1, and we can look at it graphically, or we can just look from the left and right side, And since they both equal, we know that the limit of f of x as x approaches negative 1 will also be 2. Alright, but if we look at 2, we see we did it from the left and right, but since they are different values, that would mean that the limit of just 2 does not exist because the left and right must be equal to each other. When we come over here, we look at 5. We done 5? Nope. So let's go look at 5. So at 5, from the left side, so this arrow continues going. So from the left side, it hits negative 2. And if this arrow is to keep going, if I backtrack back up, I would see that it's also going to be negative 2. So an arrow indicates a straight line that just kind of keeps on going. So both from the left and right, it actually approaches at negative 2. Alright, so as the limit of f of x as x approaches 0. So let's look at 0 now. So here's 0. The only thing that's on 0 is negative 1, both from the left and the right. And then we have 1. So if we look at 1, again, both from the left and right, it happens to also be negative 2. Alright, so make sure you get all that written down and continue on to the next video.